Hello, and welcome to the research poster presented at the 53rd Lunar and Planetary Science Conference. You're either viewing this video during the poster session since I'm away from my poster, or you are viewing this after the conference has passed. You can pause the video at any time to read the text and explore the figures. My poster is a presentation of just a portion of my PhD work at the University of Nevada, Reno. This work uses drill core from the Hawaiian Islands as a subsurface alteration analog to Mars. As we know, there are observations of altered basalt on Mars into minerals including phyllosilicates, sulfates, and carbonates, and at times these minerals are observed to be in close proximity to each other. Our current findings show that these basalts in Hawaii exhibit similar alteration mineralogy like those observed on Mars. Therefore, conclusions that come from our work, which characterize the alteration evolution of basalts, can help illuminate alteration pathways of subsurface basalts on Mars that are now exposed via cratering and other erosion events. So we have access to 2 drill core from an external project funded by the U.S. Army. The original Army-funded drilling project was an exploration effort to find groundwater resources in the Humula Saddle, Hawaii, which resulted in the PTA and KMA cores, about 10 kilometers from each other. The PTA was surveyed in the shortwave infrared in 2014, and the KMA core was surveyed this past summer in August of 2021. So these 2 sections serve to visualize the distribution of mineralogy in each drill core using spectral analysis software. Generally speaking, both cores demonstrate very distinct alteration types. On the left, we have the KMA, which exhibits acid sulfate alteration with some smectite minerals. These smectite minerals do not correlate to acid sulfate mineral formation, and it is unclear what their existence is with respect to the subsurface environment. The PTA on the right exhibits phyllosilicate and zeolite minerals. Because we are focusing on our most recent survey of the KMA, I'd like to bring to light of some of our current hypotheses and models. The alteration mineralogy in the KMA core is strongly correlated to groundwater and core loss. During drilling, it was noted that there was a series of well-consolidated cap units that are likely ash or dense flows, followed by a perturbation of a confined aquifer under immense hydrostatic pressure. The rocks existing in the aquifers were porous and permeable. Although sulfate minerals such as jarosite can help narrow down the environment of formation to a pH constraint, we still need to determine whether the alteration is hypogene or supergene. Circling back to the original goals of the drilling project, the 2 wells were used to assess the extent of a potential aquifer in the region. We find in both the groundwater logs and in the mineralogy that both wells are cut off from each other, likely by vertical diking and intrusion. This has huge implications for subsurface environments on Mars. The study of these 2 drill core demonstrate that bearing events during the construction of the shield volcano act as a control on the flow of water in the subsurface, which contribute to the subsequent reactions that take place between rock and water, creating variable alteration. Additionally, I would also like to point out the detection of iron and magnesium smectites in the KMA core. Although they are not as pervasive, their presence is still intriguing as smectites are also seen to coexist in sulfate-bearing units on Mars. Figuring out whether it is chronological formation or specific geochemistry can help bring light to similar patterns observed on the Martian surface. Of course, like any research, more work needs to be done. Although we focus on spectroscopy, we believe that these higher resolution methods will help contribute to the overall understanding of subsurface environments on Mars. If you would like to chat more about my work and you are unable to reach me at LPSC, I would like to guide you to my personal webpage where there is a contact tab. Please do not hesitate to contact me with questions, comments, or even concerns about my research. I also welcome literary and data contributions as well. Thank you so much and have a great day.